The question about tools and what tools to use and why one would use one set of tools rather than another is a very interesting one, and in a sense comes to the core of the problems. You can't express yourself without the tools, and in order to choose the right tools, you have to really have an understanding of what it is you do. And ironically, that may mean come to an understanding that you don't know what it is you're doing. In other words, you don't know where the solution is, so you need a set of tools which allows you to explore. So, from a point of view of a composer, I don't know the piece is finished till it's finished. It's not an engineering problem. Writing music is not an engineering problem where I say, well, I have these elements and this and that, so I'll find a tool which I know will stitch them all together, and in the end I'll end up with a composition, or a sonification for that matter. It doesn't work like that, because you build and you iterate and you change and you go. The tools can take you off, or your ideas can take you off into one direction, or they can take you off into another direction. And at some point you have to make a decision based on your sense of what's going on, because there's far too many decisions that you've made along the way. You make thousands and thousands and thousands of decisions each moment you're working with a sense of where it is you're going. And unless you have tools which can adapt to that way of working, it makes it very difficult to iterate. So for sonification, the big mistake I think people make in sonification, especially people who come to it fresh, is that they think sonification is about making sound. So what we do is we find the best tools for making sound, and then we'll worry about everything else after that. And there's a trap to do that, I think, because data sonification is not just about sonification, it's about data. And most of the tools which make sound very well come out of music composition and not out of data processing. So when you are making a piece of music, you're saying, I have an idea, I have a sense of how it wants to sound, I have a set of tools which people have made music with, that I understand, that people have used to make music with, and I make the piece using those set of tools. In data sonification, what you have is you've got the data. That's the first thing. You don't know what it's like, really. You have some sense of it. It's not till you start to play with it that you understand what you've got to do with the data. And you're not sonifying the data, but you're sonifying the information in the data. So you have to have tools to extract the information out of the data before you can even start to go anywhere near sound. Like in the NetSon project, I spent months without making any sound at all, just by trying to understand the data. And so I need a set of tools which allow me to process the data. And it's not necessarily the case that the tools that are best for making sound are the tools that are best for processing data. So if you make the decision, I'm making a sonification, therefore I'm going to choose tool X, which is known to be very good in making sound, and then suddenly you have to do multi-dimensional array processing with all sorts of outer products and whatever it is you've got to do in order to do noise reduction on the data, and there's no tool within the composition, the sound making tool set to do that, you're stuck. And because you've made a commitment to make sound with this tool, you have to find a way of doing the data processing, which may mean you've got to do it yourself, you've got to write the tool yourself, or it may mean that you've got to wait for someone else to do the tool, make the tool. So the more I thought about that problem, the more I realized that you really have to start to build a set of tools which have all those things incorporated in them. And that means you don't have a tool which starts out being a sound generation tool. Sound generation is very important, but you need to find a way of gluing different tools together, which have expertise or have embedded in them these, like, there are people who do, for their living, for their lives, they think about how to efficiently do multi-dimensional array processing. So the idea that I would come along with a fantastic sound tool, need multi-dimensional array processing, then write it myself. So I stop everything I'm doing and until I write a multi-dimensional array processor, when out there in the outside world, in the computing world, there are these fantastic tools for doing that. What I have to try and do is put them together. It means that if you get caught very early, if you focus on sound, of course you need to make sound. So for my way of thinking, it's one of the reasons that I've developed this environment called SoniPi, because I started to look for tools which allowed me to do a wide range of data processing, mathematical calculation, graphical output as well, but at the same time make sound synthesis. And the combination that I've found which best does that is Python for processing, Python for everything that's not sound, maybe with libraries that do things like, the thing about Python is that you can wrap rapid code, rapid result development that's written in C or C++ or something like that. And then a Python wrapper around C-Sound. I use C-Sound because it's the oldest and it wraps, it's the one that's got the best wrapper. Python wrapper for it. So you end up using Python, I end up using Python as a way of communicating between all these different processes that are happening in different libraries. And, well, I haven't yet to find a better solution. What I find is that people come to me with a problem about, they start the sonification process and they get stuck. And the reason they get stuck is because they haven't realized that part of the problem is actually just as important as any other part of the problem, like data processing or like graphic output, or because as we know, we don't just do sound, we often do graphic output as well, like mixing, like whatever. And mostly the tools that are built for music composition don't have all those dimensions to it. A bit like, because of the way we talked about earlier, the music competition tends to be very platonic. It's not really dealing with the outside world. You can generate algorithms with it. But the moment you've got to deal with the outside world, things are a bit complex. And it's getting better with tools. Super Collider is another tool which I suppose would be my second choice, because the synthesis engine is separated from the event processing, and all the communication is done through, in this case it's OSC, a protocol. It's UDP essentially, it's UDP. The communication, there's a separation of the synthesis engine and the language around it. So Super Collider is a good alternative for that, but you still need a tool dealing with the data and those sorts of issues. So that's why I come down on that approach, rather than saying, right, I'm going to make sound in, say, Chuck, which is a fabulous sound synthesis environment, and then you get to the problem of what do I do with data? Oh, it's got to be in a text file. Well, that's no good if I'm real time. I need to be able to process data in real time. So anyway, that's my take on how to think about tools for sonification.